Hello viewers, welcome to Maths 24 or the Maths Super Channel and the GCE Maths panel. In this particular lesson, we are presenting inequalities with absolute values, also known as absolute value inequalities. I am Dr. Miles, your host, and it's very important that you make sure that you follow this particular lesson or video to the very end. At the bottom of this video equally, we have a quiz and lesson notes for this video. Welcome once more. I am Dr. Miles. Let's begin with this absolute value inequality. The absolute value of 2x minus 5 strictly less than 7. Now, when you have an absolute value inequality like this, using the less than, it is broken down into absolute value of a less than b, then it becomes a lying in the interval of minus b to plus b, as you can see on the top right. However, if you have less than or equal to, we have the same thing, and it just adds the equal to beneath the less than sign. Now let's see how we are going to split this equation. So note that absolute values cannot be equal to a negative number. In this particular case, the value of b must be positive. If b is negative, then there is no solution. Why? This is because an absolute value can never be negative. So the absolute value of this can never be less than a negative number. So we split down this into 2x minus 5 is strictly greater than minus 7, that's the negative of this 7, and less than the positive of it, just like it has been explained here. There are other ways to break it down, but this is what we do. So simplifying, we add minus 5, or we add 5 all through, and we will have minus 7 plus 5, which is minus 2, and here we are left 2x less than 12. You see that 2 is still common, and we can divide all through by 6, and this gives us the solution to be x lying between minus 1 and 6. This is the solution. Another way is to use the union to break it. Here we are going to say minus 7, that's the minus of this is the b value, right? The minus 7 to be less than 2x minus 5 union 2x now minus 5 less than the positive value plus 7, and we solve them separately and we arrive at the same answer. At the end here, you see that x is greater than minus 1 and less than 6, which can be brought together same as what we had before. The second question reads the absolute value of x plus 11 less than or equal to 7. So we are equally going to break it into x plus 11 is greater than minus 7 and less than plus 7. We subtract 11 all through and you'll be left with minus 18 less than x less than minus 4, and that gives us the solution directly. We can equally use the union to break, and this is the solution that we will have. We have the same solution. Most of the times when you finish solving absolute value inequalities, it's good to express a number on a number line. Let's take this third question. The third question reads the absolute value of x plus 11 less than or equal to minus 7. There is something I would like you to observe here. Look at this value here. On the left hand side, we have an absolute value. This means this number here is positive. Now the question is, can a positive number be less than a negative number? The answer is no. So what is the solution to this problem? We know that absolute values cannot be less than a negative number. For example, 2x minus 5 absolutely cannot be less than 7. So this particular problem has no solution. There is no solution because it is not possible. However, an equation of the form ax plus b strictly greater than or equal to 0 takes all values of x. So this particular one will take all values of x, as you can see, and this one will have values of x that we need to solve for. Question number 4, we have 3x plus 4 absolute value greater than 5. Now here we have greater than, and how do we break the greater than? If the absolute value of a is greater than b, then a is less than the negative of b, or a is greater than the positive of b. So in this case, our a here is 3x plus 4. So this 3x plus 4 is less than the negative of this number. So 3x plus 4 is less than negative 5, or 3x plus 4 is greater than the positive. That's how we split it here. As you can see, these two are the same. The only difference is that here we have less than or equal to, greater than or equal to, and the other one we have just greater than. And we solve these two equations separately, and the end result gives us x to be strictly less than minus 3 union x to be strictly greater than a third. Let's take the next question. We have 2 times the absolute value of 5 minus 4x to be greater than or equal to 5. And here we have to note that when we have greater than or equal to, as I explained before, ax plus b is greater than or equal to c, or ax plus b is less than or equal to minus c. So here I'll first of all make sure that I divide all through by these two so that it looks exactly like this form. I can still solve like this, but let me divide still. So we have 5 minus 4x absolute is greater than or equal to 2.5, or you can work with fractions. The next step, you can now split it using what we have here. So 5 minus 4x is greater than or equal to 2.5 union 5 minus 4x is less than or equal to the negative of it. And we solve these two separately, and our end result is x is less than or equal to 0.625 union x is greater than or equal to 1.875. That's question 5, and now question 6. For question number 6, so here there is something I'd like us to note before we move to question number 6. You find out that here, before they obtain the value of x, they divided both sides here by minus 4. And whenever you divide both sides of an inequality by a negative number, if you divide by a positive number, it remains the same. The inequality sign remains the same. But whenever you divide by a negative number, the inequality sign reverses. Here we had greater than or equal to. It has become less than or equal to y, because divided both sides by a negative 4. And it's the same thing that has been done here. The inequality sign has reversed. That's why we have these yellow flashes or arrows indicating. Let's take question number 6. We are moving to more tough questions. So here we have absolute values greater than or equal to absolute value. So with this type, we just square both sides. When you have this type of questions, absolute value is greater than or equal to absolute value, or less than or equal to absolute value, we square both sides. So squaring both sides gives us x squared plus 4x plus 4 is greater than or equal to x squared plus 2x plus 1. And when we simplify this, just like solving a simple linear inequality, our final result will be x to be greater than or equal to minus 3 on 2. So most of the time when we have absolute value is greater than or equal to absolute value or less than, and the coefficients of x are the same, we usually have a single root. Whenever the coefficients of x are not the same, that means, for example, we have 2x here and here we have just 1x, then we expect to have one or more roots, maybe repeated or distinct roots. For question 7, with this type of equations, just like the previous one, whenever you have an equation like this, you can either square both sides or you use the rule to separate them. You use the rule. So here, squaring both sides, this is what has been obtained. If you square both sides, this is the solution that you will have, just like the previous one we had, right? Now, if you decide to use the rule, you have x minus 1 to be greater than or equal to 3 minus x, or x minus 1 to be less than or equal to the negative of this right hand side. And when we solve the two separately, this is what we have. But the right hand side, we have x here and x here as well. So in this case, there is no x to solve for, there is no variable. So we just continue just what you have on the left hand side. And we have the same solution, as you can see. So here we have alternative ways to do it. And as I've mentioned before, when you have this absolute greater than or equal to a quantity like this, it is the same like you can use the same procedure as absolute is greater than or equal to absolute and square both sides, or you use the rule. For question number 8, we have the absolute value of a fraction is less than a particular number. Absolute value of a fraction. In this particular case, we can multiply both sides by the denominator there. The denominator is x minus 1, and since it's an absolute value, because you are being told that you should not multiply both sides of an inequality by a number whose sign is not known. For example, a variable. You should not multiply both sides by x because you don't know the sign of x and how it will affect the sign. But here, since this x minus 1 is an absolute value, you can multiply both sides with, because the absolute value of a number is positive, and that is why this has been done like this. Otherwise, I have no right to do this. After multiplying both sides by this, it will be best for me to square both sides. Squaring both sides will be faster, because if I try to make it complex, it takes a lot of time and a lot of mistakes might follow. So we square both sides and we simplify. We obtain quadratics on both sides, and we further simplify to have a quadratic, which is 4x squared minus 10x plus 4 is greater than 0. And the best thing to do with this is to factorize. When you factorize this, you have 4x squared minus 8x minus 2x plus 4. So I'm looking for AC, just like you have done in secondary school. I'm factorizing step by step. So my AC is, that is 4 times 4, which is 16. And I now look at two factors of 16. That when you multiply by 16, you have 16. And when you add them, you have negative 10. And those two factors are minus 8 and 2. And minus 2. So minus 8 times minus 2 is plus 16. And when you add minus 8 to minus 2, it gives us minus 10, which is this middle term here. So I have broken down this my quadratic into these terms, as you already know. And now when you continue to factorize, I see that here 4x is common in this bracket. I factor it out, and this other bracket 2 is common. You factor it out. At the end, we are left this common factor, which is x minus 2 in both brackets. We factor it out completely, and we finally have 4x minus 2 into x minus 2 to be greater than 0. Note that I can carry this to the right hand side, but I'm just working with it like this. So at this point, the boundary solutions means when you equate these ones to 0. Note that for an inequality, it is a range of values. So for the boundary solutions, if we equate this to 0, you have x to be equal to a half or x is equal to 2. So it therefore means my results either lie between x equals a half and x equals 2, or above 2 or below a half. So when you look at a half and 2, we can test. Take any value below this and test. For example, let's take 0. If x equals 0, let's test here. In this set, we will have minus 2 because 4 times 0 is 0. So minus 2 times minus 2 is plus. And is this one greater than 0? Yes, it's greater than 0 because 4 is greater than 0. It means that the region below a half is satisfying this inequality. Now let's take another number above 2. If we take above 2, 3, for example, 4 times 3 is 12. 12 minus 2, this one becomes positive. 3 minus 2, this one becomes positive. Positive times positive is positive. So any number above 2 equally satisfies this inequality because that number will give us a value greater than 0. But if we take a number between 1 and 2, 1 for example, when you put 1 here, this one is negative and this one is positive. So it therefore means that the region is below a half and above 2. Let's look at question number 9. So with this type, it is best to first of all multiply both sides by the denominator just like we did before, and then we square both sides and simplify. So it is just the same procedure. So what does this give us? When you simplify, we will have finally, we have 4x minus 2 absolute value is less than a third. You can use the rule now to simplify, or you can just decide and you go ahead. And when you solve this particular question, your result will be x lying in the interval between 5 on 12 and 7 on 12. Question 10. Don't forget to click on the subscription button and to take the quiz that follows this particular lesson. If you cannot get to this lesson, you can go to our blog www.gcemathspanel.blogspot.com, or just go to Google and type GCE Math Panel online classes Google sites, and you equally come to this blog where you see all our lessons for ordinary level and advanced level of secondary school and high school. Now this is a question that came the past year, and I was making this video and I saw it necessary to put it here. This is a very simple question. You just have to bring like terms together. When you bring like terms together here, you have 2 times the absolute value of x to be greater than 2. Divide both sides by 2, you have the absolute value of x greater than 1. And when you use the rule, it will give the answer directly. X is greater than 1 or x is less than negative 1. Question 11. For question 11, we have yes, this is the same like the other question we solved before. We just multiply both sides by the absolute value of that denominator there, and that's all. We can decide equally to use the rule to break it down. Whatever method we use, we arrive at the same answer. So we can simplify all of this. Let me just go through very fast. So whatever method you use, we will arrive at the same answer. Alright, don't forget to leave your comments below as we look at the last question, question number 12, which is a very, very, very tough question. And I'd like you guys to solve this question and upload your answers in the link below. Or you can go to our blog and leave your comments under this particular video. So let's see what we have. Yes, this is a very tough question, and we would like you to take this challenge of the year, solve this question below, and present your solution. Let's see what you have. Thank you so much. We will now be taking a summary of the chapter. So here is a summary of the chapter. If you have the absolute value of ax plus b to be less than c, then this is how you break it down. If you have the absolute value of ax plus b is equal to c, this is how we break it down. As you can see, just the signs have changed. And if you have the absolute value to be greater than c, this is how we equally break it down. In this particular case, we saw this in the previous lesson, that is lesson 1a, which is on absolute value equations. And here in lesson 1b, we look at absolute value in equations or inequalities. So here we give a summary equally in a better way. So when you have this type for absolute value inequalities, if you have any of these forms, square both sides or apply the rule. If you have any of these, square both sides or apply the rule. If you have this other one, you apply the rule, then bring like terms together or write it in this form. Since the denominator is an absolute value, you write it in this form, that is multiplying both sides by the denominator, and then you square them and simplify. If you have this other form, just square both sides. Here, just square both sides. With this other one, you group like terms. This is the last example we saw. And if you have this one, know that there is no solution. If you have this other one, then all real numbers satisfy. However, if the value of b is equal to 0, then all real numbers. If you have this other one as well, all real numbers. It doesn't matter also what the value of b may be. You can see in an example that we're going to do. With this one, you have to do multiple splits. So this is some sort of a hint. You have to do multiple splits. If you look at the previous lesson, you see how we did multiple splits. Okay, thank you so much. Our next lesson is on surds and roots. Please make sure that you watch this lesson to the end and take the quiz. Welcome once more to the GCE Maths panel, to Maths 24, and to the Maths Super Channel. We say hello to all our fans there in Canada, here in the United States of America, and in Africa. Thank you so much. I have been Dr. Miles, your host. Bye bye.